Hi. Hello everyone, my name is Alexander Rudenko and I'm a community lead at Facebook Developer Circle Moscow. Uh, Today we have a second day of our front-end online meetup series. Yesterday we had three themes. The first is about GSL approach in front-end development, and the second one is about evolution of front-end. And the third was about a factor and how about new state manager factor. Today we want to start with Vitaly from Yandex. Vitaly, hello. You can share your screen and start your presentation. Please welcome.
Okay. Hi. Let me have to start it. Hello, everyone. I'm Vitaly from Yandex, and I'm gonna tell you what's beyond Create React app. Oh, why it's not clicking? It looks how, yeah, it hangs on, and I don't see my cursor, my pointer. Yes, it looks like I have to, tell the next guy he can start.
Okay, Taravi. Okay, so let's start with Alex. Alex, are you here?
Yes, I'm here. Hello, everyone. Just give me a couple of seconds to set everything up. I'm just going to share my screen. Vitaly, could you please stop sharing your screen so I can share mine?
Vitaly?
All right. I think I got it. All right. Just let me know if you can see it.
Okay.
Does it work?
Nope,
Hello?
we don't see. Oh.
Just a sec.
Okay.
What about now?
Now, yep. Yes.
All right.
All is fine.
Right. Good.
Okay.
All right, cool. Let's start then. Hello, everyone. I'm here to talk about serverless. And yeah, let's get started. The thing is that serverless isn't the new thing. It came out around 5 years ago, but still there's some practical examples that I'm going to show today at this talk that I find quite fascinating. But first of all, let me tell a few words about myself. I'm Alex. I work at the company called Resume.io, which is basically an online resume builder. And this is the company I co-founded 4 years ago, and I was leading the development team. And because of that, I don't actually write a lot of code anymore. I do mostly management and stuff, but I still love JavaScript and Ruby. And most of all, I love designing things. I love designing backends, how they work, microservices and stuff. And finally, I also have like a hobby project that I'm working on, actually two. I am an amateur open source contributor. So I'm quite fond of micro libraries for React. And I have two projects that worth checking out if you have time. The first one is like a micro React router, and the second one is a tiny but powerful color picker for React. So I'd like to first start with the how serverless looks like in 2020. The thing is that in networking, in building network apps, there are two fundamental problems. The first one is developers would like to increase throughput. So basically what it means is that your app can handle as much requests as possible. And usually this can be done by applying either horizontal scaling or tweaking your network configuration. But there's actually another problem. The second one is trying to reduce latency. Latency is a feature of your app that tells how fast you can process requests. And turns out it's really hard. So there are a few techniques that you can use in order to reduce latency, such as caching or geo-distributing your servers around the world, but it's quite hard still. But the thing is, serverless aims to solve both of these problems. And when I say serverless, it's not exactly correct because obviously servers are involved behind the scenes. And there's actually a better term called functions as a service. But just for the brevity, I'm going to go with serverless in this talk. And let's just take a look at what serverless is, just a quick introduction. Basically, it's a function written in any language. Usually, like in this talk, I'm going to talk about JavaScript, obviously. So let's consider that this is a JavaScript function. And there are multiple ways when this function could be invoked. First of all, you can send an HTTP request and get the result back. And also some systems support event-based invocation. For example, if you're running an event queue or you have internet that pings, something happens, the function is called. And what's cool about serverless is that these functions, they can be infinitely scalable. What it means is that when you have more requests coming in, or let's say your app suddenly have more traffic, let's say it's a Black Friday, you don't have to worry about scaling your app. It just works. The provider of serverless will add more resources, so it's totally hidden. So you don't have to worry about that at all. And the final thing is that you only have to pay for the compute resources that you use. In some providers, the boundary is down to 100 milliseconds. And when serverless was first introduced in 2016, I guess, with AWS Lambda, and it was kind of a breakthrough. A lot of the media was talking about that a lot. And then a couple of years after, we saw some new providers joining the market as well. So now every big player on the market has their own serverless solution, such as Google Cloud Functions or Azure or IBM. Even Yandex has serverless, you could check it out. But I would like to also outline a different category of serverless providers. And they usually build on top of like big providers like AWS. And these are called deployment platforms or smart CDNs. There are currently two companies that are running smart CDNs, Vercel and Netlify. You have probably heard about them because they are super developer friendly. They provide good developer experience, but at the same time, they're less configurable, which means that if you need to have a custom serverless solution, you probably have to stick with AWS Lambda. But if you're building a regular app, I would recommend going ahead with these platforms. And then there is a different sort of serverless providers, which I would like to call edge computing providers. And probably the biggest player in the market right now is Cloudflare Workers. And we're going to talk about that a little bit later on. So in this talk, we're going to focus on mostly Vercel and Cloudflare. And the reasons are that they're both CDN based, and they also provide great developer experience. And finally, if you know how to build programs with Vercel and Cloudflare, you don't have to worry about other providers because like the rules could be applied. So I would say 99% of the cases could be handled if you know how Vercel and Cloudflare works. So I would like to first start with Vercel and building so-called general purpose lambdas. So basically functions that can do like day-to-day things like rendering or APIs and stuff like that. In order to do that, let's take a look at the example of the code that you can use with Vercel. So this is the code snippet. It's written in JavaScript. And there are a few things that I'd like to mention here. First of all, as we can see, Vercel supports node dependencies. So you can use NPM, you can use Yarn as well. you can add more dependencies to your package.json, and then you can import those dependencies from your file, from your function. The second thing is that these functions, they could be asynchronous. So they support async await out of the box. You don't have to compile it. So it's all transpiled by Vercel internally. And the final thing is that these response and request objects, they're actually HTTP response from Node, but with a bit of an extension, because they have quite convenient helpers that you can use. For example, this one that just returns JSON, sets the proper content type, and so on. But probably the most fascinating thing about Vercel is that it's just a one command, zero config deployment thing. So you just have to type Vercel in your terminal, and then like 1 minute later, your app is online and available globally. And in this case, we have created a file api/stars.js, and Vercel detects that, and it will automatically create an API endpoint, api/stars. Now, let's talk about a real example of how Vercel lambdas could be used in real life. And I'd like to start with the server-side PDF rendering microservice that we at Resume.ai use. So here's the context of the problem. We have Resume Builder, and we would like to, once you type, you would like to see the updates propagate in the real time. So you want to see the preview updated in the real time on the right-hand side. We have done it with React PDF, which is a library that uses React renderer to produce a PDF. And it works pretty well entirely in the browser. So the preview, the PDF generation, the drawing, entirely done on the browser side. But here's the thing, it's not really well supported in some browsers, such as IE or mobile browsers that do not have enough capabilities. So if you would like to run, if you wanted to run React PDF in these browsers, it just won't work. So in that case, we realized that we needed some kind of a fallback, like a backend thing that essentially just accepts a JSON of a resume and then responds with the PDF file. Cool, right? Well, here's how we assumed it would work like. So we have a backend, then we have a browser, and we have a Lambda. And the thing is that we do not want to call the Lambda from the backend. We want to make it working entirely from the browser. Well, we already know how to write simple Vercel functions, but the first challenge that we had was how to authorize requests. So how would Lambda know that the requests have authorized? So we solved that with the JSON web tokens, but that are signed with asymmetric ciphers. And let's just see how it looks like. So JSON web token is a base 64 string that consists of 3 parts. The first one is like a static header, doesn't change that much. The second thing, which is probably the most important one, is a payload. So essentially just a JSON with some user data. And in our example, we provide an ID of the user, their plan, and the expiration date of that token. And the final thing, which is essential for the authorization part, is signature. So basically what we do is we take the payload and we sign it with an encryption algorithm, but we use an asymmetric cipher. So it means that only backend can issue the signature, but everyone else could verify it. So which works pretty well in our case, because we could issue JWT on the backend, then pass it down to the browser. The browser then takes this JWT and attaches it to the Lambda call with authorization header. And then finally, Lambda has everything. It doesn't have to talk to the backend, so it's fully decoupled. And it knows what the user is it authorized, like token lifetime and so on. So great. So now we figured out how to do authorization. But then we realized that lambdas are just functions. They're not real Node.js programs. So if you do something from repeatedly, you will have a question like, is it possible to maybe reuse allocated resources? And what I mean by that is let's take a look at this piece of code. So this is a simple function that takes the user info from the database. And in order to talk to the database, you have to first get the connection. And this part here is problematic because when you want to have a TCP connection instantiated, you have to send a few packets back and forth. So this is a potential source of latency. So how could we eliminate that? Well, there are two facts that could help us. First of all, what we know for sure that one Lambda can only process one request at a time. This is how Lambda work, and when we talk about Versal, it uses AWS internally, so we know that for sure. And the final thing is that a Lambda could be reused between requests. So this is like a sort of a implementation thing, but we know that for sure because our serverless providers, they do that because they want to have faster requests. So usually when Lambda just starts, this is called a cold start. It takes time. But then if you have a request coming in, there is no need to just shut it down immediately. You could just keep your Lambda active for some amount of time. So this is actually cool because we could exploit that in order to reuse resources. So this is how we solve that problem. So basically, you could write a function that instead of just every time connecting to the database, it takes the database connection pool from the global variable, which I must say is considered to be an anti-pattern in serverless. But still, you could create a global variable. You could check if this variable is null. If it's not, then you take this pool, and then you could acquire a connection from the pool. So this could add a significant decrease to the response time, so it could be faster. And the final thing that we noticed when working on this implementation is that, like usually when you work with just one function, it's fine. But if you have like 2, 3, or more functions, and you have probably pieces that are repetitive, and usually this is just an authorization thing or maybe error handling. So the thing is that there is no middleware, so it's not an express thing. So you cannot use middlewares, but actually you can if you assume that the lambdas are just plain JavaScript functions. So this is how we solve that. So it's just a high order function that takes your lambda, wraps it, and does some logic, and then passes the execution down to the original function. It's pretty simple, and I love it because it's simple, verbose, and really easy to maintain. So when we launched this project, the results were really interesting. First of all, we noticed that the response is usually between 400 and even 2 seconds of rendering. Of course, depending on the document size. So if you have large PDF, it takes like 1.5 seconds to render the document, but usually it's below 1 second still. We deployed this thing in March 2019, and it's still running. So we didn't have to care about any operations whatsoever. It's been up and running. It's like 0 downtime, and it's super cool. Currently, it processes around 300 gigabytes per month of PDFs. And the final thing that we noticed is that when we launched this thing, the conversion rate increased a little bit, which was also a bit interesting. Now, I would like to tell about the second use case, kind of similar to the previous one, but a bit different, that it assumes that in our resume app, we have this dashboard where you see all of your resumes, and we wanted to have an image preview of a resume. But we didn't want to run a PDF rendering in the browser because, first of all, it's resource consuming. And second of all, I mean, if you have 10 documents, you're going to have to wait until every document processes. So we figured that we needed some kind of a way to take the ID of the resume and then return a JPEG. But the problem is it still could render under 2 seconds. We don't know for sure, but the response time could be 2 seconds. So for this particular use case, that's unacceptable because obviously no one would like to wait 2 seconds until the image is loaded. And here That's the point where I would like to introduce this next thing called smart CDNs. And let's just take a break and try to figure out what smart CDNs are. Guillermo Rauch, the creator of Vercel, he once said that he described Vercel as a CDN that is capable of executing code. And I think this is pretty much the best explanation of what smart CDN is. And when we talk about Vercel, they have this really nice feature that you can use, and it's actually it works like that. So if you take the response of your Lambda function, if you attach a header called cache control, which is similar to the regular cache control header used everywhere, you could tell Vercel to cache the result of this Lambda function in the edge location. So what I mean by that is that Vercel will take the result of Lambda and save it somewhere near you. So in this case, it will be available for 24 hours. Remember that this is not a browser caching, because Vercel will still respond with cache control, no cache, to the browser. But at the same time, the response will be around 20 to 30 milliseconds. So it's quite fast because they have a nice network of CDN servers. So here's how it looks like. Let's say you're calling your code from San Francisco for the first time. There is obviously a cache miss, so you have to call Lambda, and the result is like around 800 milliseconds. Kind of okay, but yeah, could be better. And then let's say you call it again, but now the result is already in the cache, so response with 20 milliseconds. But one thing to keep in mind is that if you call the same function with the same arguments from a different location, Vercel doesn't propagate the result around the globe. So it will invalidate the cache, and so the cache is edge specific. So we ended up with this thing, basically just an API that allows us to write an ID of the resume, page number. You could specify format of the document, and then it returns back the thumbnail of this resume. And I would like to also point out that there is a query parameter called version. So we use that in order to invalidate the cache. So let's say you change your resume, and in this case, we would like this preview to be updated. When we talk about regular browser caches, if you use query parameters, it will not be cached. But in case of the Vercel, it works like that. So if query parameters do not change, you get the same result. There's actually another use case that I would like to mention just because it's kind of awesome, but it's just the same. It uses exactly the same technique, basically. So we needed some way in our app to display a set of randomly generated avatars for the visitors of your resume. And we figured out that we could just take the parts of the head and then generate the random image based on some ID. So build a Vercel Lambda that responds with ASVG. The result is cached with cache control header, and also it is randomly generated based on the ID. So let's say if I call Alex, it will always return the same image. But here's the problem: the first request is still slow. So what if your application is like really picky about the response time? What if you cannot allow your clients to wait for 2 seconds or more to load the data? Well, actually, there is a workaround, and this is one of the best features of Vercel, is that they support stale while revalidate. I'm not sure, but I don't think any other platform supports that. So actually this standard was intended to be used in browsers, but I think in Vercel, it's even a better use case. So basically what it means is that you could respond with cached version, but at the same time, you could revalidate the cache in the background. So let's say you call your function for the first time, you get the result, and then the second time you get the cached version. And then after 1 minute, which is like the first interval, you call it again. You got back a cached version of your response, but at the same time, Vercel will revalidate it in the background. So next time someone calls it, it's always fast but it now returns a different version of the response. Cool. So with stale while revalidate, we also use it in a different use case. So we also needed some kind of a way to show OG images for Facebook or any other social platform. So if you share your resume online, we would like to show like real resume instead of a placeholder. And in this case, response time, is critical. And we figured that the resumes for OG, doesn't matter if they're sometimes stale, it's fine if they're not up to date, but the content doesn't change frequently, so we can do that. So, which is, I think, pretty handy. All right, so now it's time to talk about a different sort of type of serverless, which is edge computing. And I'm gonna take a look at the Cloudflare workers and their platform. First of all, I would like to briefly explain what Cloudflare is, because understanding how it works will get you better understanding of what is edge computing. So let's go back 10 years. And in 2020, Cloudflare was founded. So it was first intended to be like sort of a proxy between your end user and your server. In this schema, it's called origin server. So let's say you have an origin server in San Francisco, and your client is somewhere else in, I don't know, I think it's Asia, but anyway, on a different continent. So when you make a request to that origin, to that website, right, you don't call it directly. Instead, you make a call to the edge location of Cloudflare. Let's say it's in Frankfurt, and then Cloudflare does the rest. What's cool about that is that Cloudflare could do a lot of cool stuff, like preventing DDoS, using up-to-date features like HTTP3 and stuff. So it's really powerful. But another thing is that they have more than 200 locations around the world. So this company is really mature. I mean, it powers half of the internet right now. So Cloudflare decided like a couple of years back that they would like to figure if it's possible to run a code on the edge. Instead of running code on the origin, what if we could run the code on the edge? So that's how Cloudflare workers were born. And basically, it's a thing that runs in V8 isolate. So it's really fast. It cold starts in 5 milliseconds because it talks to the origin. One of the coolest features of that is that it can modify request and response of the origin server. It has a lot of different APIs like crypto, fetch, URL, things that are familiar from the browser. But at the same time, there's also a downside. It's not a Node.js program. It's a different sort of JavaScript runtime that runs on the edge. It has to be fast, so that's why it has a lot of limitations. But there's no file system, there are no node modules. Like you can actually use node modules, but only pure packages, no native code. So let's take a look at the real example from our experience, which is called like injecting critical CSS on the fly. So here's the problem. We have our landing page. It is powered by Rails for some reasons, and we didn't really want it to move it to static because of some complications. Anyway, we figured to just keep it that way. But for us, a better high speed means better SEO. So for us, making sure that the experience is fast is everything. One of the problems that we had was that CSS files are render blocking. So let's say you have like a style sheet link tag. What happens when browser reaches that line is that it will block the context, the main thread, until like the first line, like the first pass of CSS is parsed. There's actually an approach that allows you to eliminate that and speed up your website a lot, which is called moving the above default CSS to the inline. So in this example, what we did is we extracted the content that will be visible during the first run, like basically the top of the web page. We extracted into a CSS. We'll put it here. And then the rest of the files, the rest of the styles that you'll probably need later, we do with preload. So it will be loaded asynchronously without blocking the main thread. Okay, so, but how do we do that? Is there a way to modify the HTML to do that? Actually, there is, of course, because it's Cloudflare, so it has a lot of functions to modify requests. one of the things that they have is HTML rewriter class. So basically, it's a class that allows you to modify HTML on the fly. It is based on Rust implementation of rewriter, so it works pretty well. So let's take a look at the really simple example of how we can modify HTML. So this is a Cloudflare worker. It might look a bit weird, but still, bear with me on this one. The first thing that we notice is that we have add event listener fetch, which is similar to service workers. And Cloudflare workers were designed after service workers. I think they're trying to move from this approach now, but initially they decided, well, what if Cloudflare is actually a service worker, but just instead of running in a browser, it runs on the edge. So you register an event listener, and then the second thing you do is we use fetch in order to talk to the origin server, and we fetch the original response. Then we use HTML rewriter class to basically apply a visitor pattern. So every time you see a div, the handler will be called. And then we transform that, and then we return it back to the client. Cool. All right, so let's take a look at the final schema for this microservice. Worker, whatever. Anyway, we have a request. It comes in. We then fetch the origin response. We take the critical CSS of that web page. We then rewrite it, the HTML, and then we return it back to the browser. Sounds easy, right? But not really, because the middle part of the schema is actually the hardest one. So extracting critical CSS automatically is pretty hard problem. And there is one solution that allows you to do that. There is a package called Critical, which uses headless Chrome under the hood. But the problem is workers do not support headless Chrome. You cannot do that. So we ended up with writing a different microservice that is actually a Vercel Lambda that runs headless Chrome. So we make a call to that Lambda instead of performing that on the edge. So the final schema looks like that. I'm not sure if I have enough time to explain this part, like the gray part, but I'll try to do my best. So basically, we use this trick because we don't want to slow down the response because it's our website. The response time is everything. The call to Vercel Lambda could take a while, like a couple of seconds. So what we do is instead of making the call, we defer it with this function wait until. So it essentially allows us to write the code after the response has been finished. And another thing is that we use this distributed cache provided by Cloudflare called key value. And it's super fast. So it propagates around the world in just milliseconds. So works pretty well. All right. The result of this experiment were pretty interesting. And I think it was worth it for sure. First of all, let's say that the CPU time, the execution time of that worker was around 5 milliseconds at 99 percentile, which is incredible. I mean, I could not imagine a Vercel Lambda running at that speed. So this is a bonus of using Cloudflare workers. It currently processes around 3 million requests per month, and our SEO rankings doubled because of that. So there's a nice increase here from Core Web Vitals report at the left-hand side. All right, so let's just conclude everything what I've just said. Today we got a brief introduction to two main technologies. First of all, Vercel and other smart CDNs. They can be applied when you want to do regular stuff like server-side rendering. You could build APIs. You could build stuff that doesn't change quite often, like blogs and SEO pages. Things that use native modules like Canvas, it's all supported. But at the same time, if you want to have low latency, high availability apps with real time, with SSR, stuff like that, you should probably go with Cloudflare workers. It has its limitations, but it's totally worth it. And speaking about real-time apps, they have recently introduced this tool called durable objects. And then I think this is the new era of serverless, which will allow us to build chats, real-time apps all around the globe in just seconds with JavaScript. All right, I will just conclude with the quote. Guillermo Raj, he said that for the longest time, CDNs, they've been just treating Origin as a black box because CDNs were invented like a long time ago. But now we see this shift that CDNs can do more and that we can push content directly to the network. And this opens up really nice capabilities in the way we use and build our apps that are becoming faster and faster. So finally, there's an appendix with resources, things that I wasn't able to cover. If you have a chance, please take a look at the dino.land website, the website of Dino, the source code, because it's built with Vercel and Cloudflare workers. And I will just leave 2 links. First one is about using Node Canvas with Vercel and headless Chrome, because there are some limitations of that as well. All right, thanks everyone.
Okay, Alex, thank you very much. It was very cool presentation, and so the questions, I think. I see we don't have any. Oh, yeah. Does anybody have questions for Alex? Oh, I have. Alex,
okay.
The first question is serverless always cost effective? Are there any examples of when serverless can be more expensive than regular servers?
Yeah, actually, there are examples of that. We experienced that. So there was one interesting use case when we were using serverless. So we wanted to build a thing that allows you to do spell checking of the text that people write in their resumes. This was a really high-load thing because once you type, you send a request and back and forth. And we noticed that we built this thing first with Vercel, but we noticed that it was super expensive. And it was probably, first of all, it was slow, and then it was expensive. And I think it's because they used this granularity and there were a lot of requests. I think when you have high traffic, I think it's better to go with just a regular approach. But if you have things that don't change that often that can be cached, you can go with serverless. So in our case, we migrated from Vercel to Docker with some load balancing. It was a bit more, it was a bit less expensive.
Okay, thank you. So the second one is about third-party services, because you have a platform, yeah, and have a main functionality in your platform. And when you use serverless, you use third-party services for your platform, as I think. So, what about cybersecurity? What about testing the functionality on third-party services?
Yeah, that's a great question. So basically, when we talk about serverless, it's always about some provider, which is a closed company like Vercel, Cloudflare, AWS. These are all just providers, right? They have closed source. So there is no way to test if they're really like secured against any attacks. But I think there are alternatives. If you want to have really nicely secured serverless, you can do that with your own stack. I think you can do that with Kubernetes, right? With Docker-based. Basically, there are platforms that allow you to spin up your own serverless solution. And finally, if you, I think the second part of the question was about debugging and things. Well, Vercel has a nice support for debugging and development. They have Vercel Dev, which allows you to have instant refresh, which allows you to track errors without reloading, like deploying your code. So there are tools and there are now alternatives. I think now serverless is much more mature than before. So we definitely have the market open. So if you would like to start with it, there are some options. Oh, he disappeared. Okay, he's here. We cannot hear you.
Guys, I'm here. So today is magic day, really. Okay, so let's continue our meetup. And the second speaker is Vitaly. Now you can start. I think there will be the there will be no any technical troubles. I think so.
Yeah, I hope it will work now.
Okay.
Yeah, let me share my screen and start. Yeah, now it's clickable. Okay, hello everyone. I'm Vitaly from Yandex, and I'm gonna tell you what's beyond Create React app. First, let me introduce myself and let me tell you a bit about my case. I came to Yandex 4 years ago, and the last 2 years I've been working as a front-end architect at the Yandex search result page. My team is responsible for designing runtime and building tools for TypeScript and React code. Yandex main product is a web search. It means that there is a search result page. It's almost like Google's page. I'm sure you know what it is. But for me, our page is more pretty. In 2018, when everyone around us was using fancy frameworks like React, Angular, Vue, we stayed with our old tech stack. And then we decided that it was time to change. And in 3 years, our front-end developers have written about 30 megabytes of TypeScript and React code. And of course, we started with Create React app. It helped us to make our first steps. But very soon we realized that Create React app is that our project is too massive for Create React app, and we ejected it. And that's why we did it. We wanted to get performant client code, and at the same time, we wanted to build this code fast. Let's get familiar with the Webpack, a building tool used inside Create React app, and the whole process of building and Create React app. Webpack starts from so-called entries of application, here it's index file, and then goes through all available import and require statements of your project. Here it starts from index and goes through project level components and libraries, and then also use node modules. And all rich code is built into chunks or bundles. And there are 2 bundles in Create React app build, main with project level code and vendor with use node modules. And there is a special piece of code which is called Bootstrap, and it's built to a separate chunk. It helps to, its purpose is, it helps build modules to cooperate in runtime. For example, it implements require and implement functions in browser. And if we apply this Create React app approach to our project as is, then we'll get 7 megabytes of minimized code. And this massive piece would be sent to browser in one go. And before client this code evaluates one, and users won't see anything. And likely it won't be fast. And that's a problem. Here we came with an idea. We have a search result page, remember? What if we build separate bundle for each search result type? Then we could send on the needed code according to the actual list of results on page. Here we would send bundles for blue and green results, and we won't send black's bundle because it's missing on this page. By the way, we could use server-side rendering to show end users the page before any client code is ready. The second issue is about handling common code. Create React app treats only node modules as a common code, and it builds this code to vendor bundle, as you remember. But what if we put all common code, including project level components and libraries, to separate chunks? Then we could build a common part of blue and green result once and send it once, even if it's not from NPM. Of course, there should be super common code, which is super common modules, which is referenced by every search result type. And we could build this code to the same chunk that holds Bootstrap and send it on every page, because this code is needed everywhere, like Bootstrap itself. And the last one. Unfortunately, Create React App doesn't support any standard way to build translations separately. It means there is no way to send only needed translations. And for example, Turkish page will load all translations aside from Turkish, which is ineffective. And that should be any way to fix it. On this slide, you should wonder how we solved all these problems and how we implemented all these ideas. I want to give you a few seconds to think about it. Okay, let's find out how we did it. What improvements we made? First set of improvements. We've decided to build separate bundles for every search result type. And so we did. Currently, we built more than 200 entries, including different types of results and implementations for different platforms like desktops, pads, and phones. Next, about common code. We've decided to put all common code, including project level common code, to separate chunks to send this code better and more effectively. And we tried to use split chunks for that. Split chunks from optimization group of Webpack's options. At first, we turned off all default behavior of split chunks. Then we added all common code, including project level common code and node modules, to a separate common group. We also made another group for asynchronous modules. And we forced Webpack to build common modules imported both as asynchronous and synchronous twice. That's a very useful option when you don't know how a model would be used. Without that option, a model once imported by dynamic import should be imported by dynamic import everywhere in your code base. And that's really difficult to ensure. And the last one, we turned off all standard heuristics of split chunks, which are supposed to give better splitting, but in fact they lead to unstable splitting when models start to jump between chunks, and chunk allocation is changed completely on each release, and that could cause problems. For example, if you use any kind of HTML differ in debugging. The third set of improvements, super common code. We decided to build super common modules with Bootstrap to the separate chunk and send it on every page. And at first, we tried to use DLL plugin for that. DLL here stands for what it usually stands, which is dynamic link library. Here is an example of with a specific configuration for Webpack for code that should be built into DLL. And here are output option and plugin configured to expose build models to a global variable. That's not the only option, but that's the most common, and we used it. And aside from standard Webpack artifacts, there is a special file, which is called manifest file. It contains all dependencies of DLL, and it's used further for subtraction from the main build. And here, DLL reference plugin does this subtraction. And here's the part of main configuration. As you've seen, DLL plugin can build separate chunk from the list of entries, but it can't include in Bootstrap code. There is no option for that, and that's not what we want. And the another downside is that DLL should be run in advance in a different Webpack instance, which is also bad because it cuts further optimization opportunities. And we decided to write our own version of DLL plugin. Not a big deal, yeah? And we called it main chunk plugin. And here's an example of its configuration, and it's used in the main build, so no prior build is needed. And it just creates a separate chunk and moves there all modules mentioned in include option with all their dependencies. And it also can cut bootstrap from all build bundles and join it to the same chunk. That's the feature we wanted to have. And that's all. And the last part, translations. We've decided to build translations separately to be able to send on the needed translations and to send on the Turkish translations on Turkish page. Before you see the solution, let's see how translations look like. With the code, we have TS translation file. With the normal files, we have TS translation files. Currently, Yandex Search supports 9 languages, so for every translated component, there is a special folder with index file and 9 files with translations. A typical translation file contains an object where keys are phrases in Russian and values are translated phrases. Really simple. The most popular recipe from the internet to build translations separately in Webpack is multi-compilation. Instead of building project once, it builds it for every language in parallel. And it's configured with an array of normal Webpack configurations. One configuration for one language. Needed translations are removed by normal model replacement plugin, which just replaces imports of index files by imports of specific translations. Of course, for different languages, there are different output files. Unfortunately, this approach didn't work for us. I patiently waited more than an hour and got out of memory error. It looks like this approach works only for small projects. And we decided to write one more plugin, just one more. And we called it multi-plugin. It works at the very last stage of compilation, and it just makes a copy of all entries bundle structure for every language and every entry. And in each copy, it replaces import index like normal replacement plugin did in multi-compilation approach. And that's all. Here's only 10% of multi-plugins code, but you can see that it's really complicated. And for me, it's more C++ code than JavaScript. However, it works super fast. It takes only 5 minutes to build our project without any errors. But here is one downside. Attentive listeners probably mentioned that multi-plugins algorithm multiplies only entries bundles translations. But what about common chunks translations? Common chunks should be multiplied also. Yes, that's true. But we decided to stop here. It didn't support that primarily to avoid making our solution even more complicated. Okay, we are almost ready to see the comparison between default Create React app and our improved version. But before that, we'll start with client performance comparison. But before that, I have to tell you about one performance metric we use. In fact, we use a lot of such metrics in A/B experiments and pull request checks. But to simplify further slides, I want to use only one. And it starts from navigation when browser sends the initial request. Then resources are loaded and JavaScript starts to evaluate. And here we would have a number of JS tasks. And among others, there are long tasks, which take 50 milliseconds or more. And if there is a 30 seconds gap after initial long task. Then we call this initial long task the last initial long task. And the time between navigation and the end of the last initial long task is time to interactive. And that metric I'll use in my performance comparison. Okay, client performance comparison. At first, I tried to turn off multi-plugin to see what effect does it have on client performance, and TTI didn't show any significant difference, and that was frustrating. We spent a lot of time on this plugin, and it looked like it didn't work. Anyway, our project is still migrating from one tech stack to another, and number of migrated results on usual page is 2 or 3, and the number of and the amount of translations is also small. And so it's only now is no difference between sending only one translation and all of them. And when this migration comes to end, we'll just repeat our measurements. Next, I turned off main chunk plugin, and TTI increased slightly, only 5%. That's not much for normal project, but at Yandex that's significant. And the last one, I tried to roll back all improvements we've made to split chunks, and TTI increased drastically, over 70%, and that's huge for every project. Okay, but what about build performance? Create app builds our project on my laptop in 3 minutes, and our super improved version takes 5:30 for the same task, and that's a pity, isn't it? However, if we turn off all improvements we've made one by one, then we'll get relatively the same results. But we can't do this, and you already know why. Because client performance is more important than build performance. Sorry, my friends developers. Okay, let's sum up all the knowledge you've got from this talk. Just repeating, split common code and super popular code to separate chunks. Use multiple entries for independent parts of your application. And try to stay away from multi-compilation, especially if you work in a large project. And one more thing, if you are wondering why Yandex Search decided to replace its tech stack, you should watch this talk. Thank you. I am open to your question.
Okay. Any does anybody have any questions? So I see we have one question from Alex. Where do you store compiled GLL bundled?
Oh, if you listened carefully, you should got that we don't use DLL right now, but when we experimented with it, we just put it with all build static to our CDN, and that's all.
Okay.
Oh, okay, okay. What's your opinion on React Webpack and all this? Do you still want to migrate to this stack?
Yeah, I don't know, we didn't find anything impossible, so we continue our work. And we also see how new developers come to the company and invent new cool features, primarily because we use these open source technologies. So it works.
Why do you don't use dynamic imports, but use entries to split application?
That's good question, and I I think I'll do a different talk about it when I gather more information about that. In our project, we use splitting based on entries, and smaller projects in our different teams tend to this dynamic import approach. And I want to compare them and do a separate talk. So just wait for it.
Okay, okay. What would you recommend to other developers in optimization of bundling?
I don't know. I think there are a lot of good articles on Medium and other social networking. So you just should search and you'll find everything you want. And of course, you can mail me, and I probably could suggest something specific for you.
Okay, okay. Any other questions, guys? Oh, we don't have.
Cool.
So, um, for this day, that's all, and we will continue our front end online tomorrow. We will start at 10 10 and 11 a.m. And see you tomorrow. Yeah.
Bye.
Thanks, everyone. Thanks for watching. Bye.